Hello and welcome back to Calculus 1. We are going to talk about derivatives of trigonometric functions. Before we do any of the derivatives, I just need to remind you of few identities that you will need. Let's do those in green. I don't use green enough. And then we'll derive derivative of sine function just because it's fun, and then we'll go on and do the 6 trig function derivatives and then have fun with problems. So here we go. Start with the fact that tangent x or tangent theta, whatever, is equal to sine x over cosine x. Cotangent x is cosine x over sine x. Secant x is 1 over cosine x. Cosecant x is 1 over sine x. Note that the first letter for secant and cosecant is always opposite of the other function, right? So as with C every time. Now we have the 3 Pythagorean identities, and those are sine squared x plus cosine squared x equals to 1. If you are to divide everywhere by cosine squared, you will get tangent squared x plus 1 equals to secant squared x, or 1 plus cotangent squared x is equal to cosecant squared x. So these are the identities that are pretty much necessary in Calculus 1. There are other useful things that are not as, important, like a double angle, sine 2x or cosine 2x. We'll review those if we run into them, okay? But for Calc 2, it will be double this amount to survive that course, and that review will be done at the end of the course. All right. So now that we know this, we also have to put down 2 limits, which you guys are now just seeing, and they will be used in this derivation that I'm going to show. But the way to do those limits will be presented later in chapter 4. So right now is he said so. All right, fine, he said so. So the first one of those is that the limit as x goes to 0 of sine x over x is equal to 1. And the other one is limit x goes to 0 of cosine x minus 1 over x is equal to 0. So these are the 2 limits that we are going to use now to derive our derivative of sine x. And then for the other ones, I'll write the formulas down, and then we'll see which ones we're going to show and which ones you guys can practice. So let's start with if I keep this on the desk. There. All right, so we are trying to figure out the derivative of sine x. Now we know that we can use the limit definition when h goes to 0. The one that you practiced also for the exam. Sine x plus h minus sine x over h. Now here's where we're going to use the formula that I did not have on the list up there, and that is the sum of two angles in a sine. So that formula is not on the list up there, but as I said, it's not used in our calculations in Calc 1, so that's why I didn't put it there. So the formula is sine x cosine h plus cosine x sine h. And then we have minus sine x to copy divided by h, which is again just a copy. And then we have limit h goes to 0. I'm going to group these guys and factor out sine. So that's going to be sine x of cosine h minus 1 divided by h. And then I'm going to break off the other one, so that's plus limit cosine x sine h divided by h. So what I did is I split this blues together and orange on a side, right? And then for blues I factored out sine. Now properties of limits say that these multiplications can be split in multiple limits. So I have limit h goes to 0 of sine x. Then I have the limit h goes to 0, so times, limit h goes to 0 of cosine h minus 1 over h, plus the limit of cosine x as h goes to 0, and finally limit of sine h over h as h goes to 0. So these are now the four limits that we have to solve. Two of which are the limits that I defined up there. If you take a look at these two, you will see sine h over h, and you will see cosine h minus 1 over h. So here's the cosine h minus 1 over h, and that was 0. And here's the sine one, which was 1. So now I have that the limit of sine x is just sine x, because there is no h in that sine x, times 0. So this one is this, and this one is that. And then we have plus cosine x times 1, because the limit of sine x over x was 1 in that formula that I gave you up there. So if you just go sine times 0 is 0, cosine times 1 is 1, so cosine x. So what we'll see in here is the full calculation to get the derivative of sine x using the standard limit definition of the derivative. Now I am asking you to, instead of going to this calculation every time you need the derivative, I'm asking you to memorize that the derivative of sine is cosine. Can we agree on that? I mean, you see the alternative. We can do the, when you go to the eye doctor, what's better, 1 or 2? 1 or 2, right? And you go like that. All the people, they know. Now the next one is d dx of cosine x is going to be equal to negative sine x. Calculation goes the same way. Those of you that are interested in mathematics and want to have a deeper knowledge and understanding, good effort, you can go and compute the other one. Now you will have cosine of x plus h, which will be cosine x cosine h minus sine x sine h. You will be still factoring and splitting up and using the same two limits to eventually get negative sine. So this is it. This is the proof of derivative of sine is cosine and derivative of cosine is negative sine. As I said, very similar calculation for the other one. Our honors students are expected to do this on the exam. And obviously everyone is expected, or should I say suggested, to memorize the formulas in the red, so you don't have to deal with this every time. So that's 2 out of 6. Great. We are at 33.333333%, right? Next one is tangent. So what is the derivative of the tangent? I will ask you to help me with this because we learned this last class. What is the tangent equal to in terms of sines and cosines? Sine over cosine. So what is this now when it's written this way? The derivative of sine over cosine. Quotient formula from last class. So now I am asking you to use the quotient formula from last class where top is f and bottom is g, or if you use u and v, top is u, bottom is v, and use that quotient formula to compute the answer for this. So I'll give you some time and then I'll solve it. Okay. Let's take a look at this together. So we are using quotient rule because we have sine divided by cosine. Now we don't write derivative anymore because the derivative is triggering quotient rule. So now we just do the quotient rule, and that would be, I always start with the denominator first by squaring the denominator. And then we have denominator as is. The derivative of sine is cosine x minus. Then we have sine x times negative cosine x as the derivative. So if you are looking at the formula and you use the f and g, then you have your gf prime minus fg prime. Something is off. This was supposed to be negative sign. Wow. Yeah, good thing that you... thanks for your help. I said this was supposed to be there, and then now you say mm-hmm. And then we have g squared. So now this is where we are going to use that sine cosine squared formula. So we have cosine squared x plus sine squared x divided by cosine squared x. This is 1 over cosine squared x, so we use the formula that I outlined here of sine squared plus cosine squared is 1. So we had that in the numerator. And 1 over cosine is secant, so this is secant squared x. So this calculation said that the derivative of tangent x is secant squared x. And I will immediately give the cotangent x. It will be negative cosecant squared x. And I'll put the red box around that. So that's 4 out of 6. The next one is another opportunity for you to practice quotient rule, because I would like to know what is the derivative of secant x, which you can write as what? Derivative of 1 over cosine. Thank you. All right, let's do the quotient rule again, since you love it so much. scroll up for 1 second. Hey, I do exactly as instructed. Alright, let's take a look. So again, take the denominator, square it. That's going to be cosine squared x. Then write the cosine x. Derivative of 1 is 0. Minus copy 1. And derivative of cosine is negative sine x. The first term, cosine times 0, is 0. Negative times negative is positive. I get sine x divided by cosine squared x. Now, I will split this into two fractions. There will be a fraction that it's 1 over cosine, leaving 1 cosine in the first. And then second cosine goes with the sine there, which is secant x tangent x. So this calculation gives us that the derivative of secant x is secant x tangent x, and the derivative of cosecant x is negative cosecant x cotangent x. And I'll put a red over that, which has the final 6. What I'm going to do now is I'm going to put all 6 of these in one spot and put a big box around it, and then we'll see what are the ways to memorize these, because they have some symmetry that you can exploit. So the derivative of sine x is cosine x. The derivative of cosine x is negative sine x. The derivative of tangent x is secant squared x. The derivative of cotangent x is negative cosecant squared x. The derivative of secant x is secant x tangent x. And finally, the derivative of cosecant x is negative cosecant x cotangent x. So these are the formulas. I put the frame around it. I hate this frame, I gotta fix this. And here are all the 6. So how do we memorize this? First off, let's note of calculus trig pairing. And if you look at the formulas, it's always sine x with cosine x, tangent x with secant x, and cotangent x with cosecant x. Without a fail, in these 6 formulas, these are the ones that are always paired together. Do we all see that? So any mention of a tangent is immediately triggering secant. Any mention of a sine triggers cosine. Right? They're all paired this way. The next, if you look left and right, those answers look the same. Sine into cosine, cosine into negative sine. Then you have tangent secant squared, cotangent cosecant squared, and then secant and cosecant both have the 2, secant tangent, cosecant cotangent. All of these that start with co, all of those that start with co are all negative. So cosine, cotangent, cosecant, they're all negative. So technically it's enough to memorize this. The other side you can reconstruct because they have the same form and they're all negative. So by memorizing 3, you should know all 6. So 90% of the time you will be using these guys here. So generally, you know, cotangent and cosecant are kind of left out. They do show, I mean, they do show up. It's not, they're never there. It's just that they're not as frequent to see as the other ones. So now, with these, we do problems. I just need to do one more modification for these formulas. I think next Saturday we are going to learn the most important technique of all for derivatives, or maybe today. Hold on. Today, that's the 3rd section, the chain rule. So yeah, we'll learn that today. So I don't have to talk about it. I wanted to add a, so sine ax, cosine ax, and so. But since we're doing chain rule, At the end of the day, don't worry about it. Problems. Well, first off, you immediately see that if I'm asking you what's the derivative of sine or cosine, you're just reciting basic formulas. So that's kind of pointless, right? What's not pointless? Well, definitely product and quotient rules involving these. So the standard homework and exam questions are, what is the derivative of x cubed sine x? That's a standard question. Or what is the derivative of sine x divided by x cubed minus 9, whatever. Right, these are the standard questions that you should see on your homework and that you will see on your exams. So we have the product rule and the quotient rule. Let's go. So the first one is product rule, right? The way it works in my head is copy the first, which is x cubed. So product rule is the way to take the derivative when you have multiplication of two functions. So we have times in between x cubed and sine x. Therefore, the first function is f, the second function is g, and the formula is fg prime plus gf prime. Primes are derivatives, right? So copy the first, x cubed, because you see ff, right? And then derivative of the second, that's g prime. Derivative of sine is cosine x. Plus, copy the second, that's sine x. And then derivative of the first, which would be 3x squared. Now remember what I said. For the sake of chapter 14, practice factoring these product rules as much as possible right away. So I can kick out x squared, which leaves me with x cosine x plus 3 sine x. And that's the answer. We're done. So now if you have to set this equal to 0 and solve it, it's easier than the top line. The bottom one is quotient rule, used when you have a quotient of two functions. We already did that 2 times. So we take the bottom, x cubed minus 9, and square it. Then we put x cubed minus 9 here. The derivative of sine is cosine x minus, and then we have the copy the sine x, and then the derivative of the inside is 3x squared. There's nothing that we can factor or simplify here. We just leave it. Yes.
Do you take points off on the test if you don't completely factor it in the product rule, or like in general?
For the third for exam on chapter 3, no. Why?
Okay.
But
I don't know if you're like
no. However, the entire problem over here, right? The entire problem over here is going to be something that you do in a margin of the, right, in chapter 4, in the margin of your problem, because the goal is to find min, max, and stuff like that. So you really don't want to say equals 0 here, because holy nightmare, right? If you say equals 0 here, then you have x squared equals 0, x equals 0 right away, and then you have to deal with this, which is, right, its own issue. So that's the reason why we want factored form as far as possible, because it gives you these individual factors which will make your next step in life easier. So that's the reason. So for exam 3, no points off. For exam 4, I don't have to bother with points off, because you will not be able to solve this as equal to 0, right? So this is not something that is imposed by me. It is something that is imposed by the nature of the beast of the problem in chapter 4. So practicing it now, as I said, is just like as a friendly, right, suggestion. Practicing it now will ease the stuff that it's coming up, because now you just worry about this one formula, right? And then you say, okay, let me do the extra step. When you get to chapter 4, I say find min and max. You go, okay, I need the derivative, I need to set it equal to 0, I need to solve the equations, the numbers that I get at critical points, I have to do the test for each one of them, right? Then in all of that mess that you have 5 or 6 different steps to do, and each one is calculation on its own, having, issues with factoring and figuring it, then it's an added headache. So you're figuring it now when it's all right, good. And thank you for the question. So this is it. Let's take a short break. When we come back, rates of change. Derivatives of rates of change. You don't have to throw the notebook,